Okay, let's now begin Chapter 2, Classical Cipher. This part will become interesting for some students, but also it will become a little bit difficult than before. In this chapter, we will introduce three parts: basic ciphering algorithms, typical classical cryptography, statistical analysis of a classical cipher. What's single table crypto system? Like a Caesar crypto system, letter A is transformed to letter D in old usage of the system, and letter A will never be changed to another letter. So we can think Caesar cipher as a given table. The table has two columns. Left column is the plain text letter. The right left column is for the cipher text letter. So you will see the first row is A and D. The second row is B and E, and so on. So when you use Caesar crypto system, you need not know how to compute. You just use this table. It will be enough. But for a multiple table crypto system, a letter in plain text will be transformed into maybe several different cipher text letters. Maybe one time the letter A is changed into letter C, but another time the letter A is transformed to letter Z, even if in one key controller. Okay, let's introduce single table basic operations. The first one and the most simple one is addition cipher. We address this part. We use English alphabet like symbols. In English table, alphabetic table, there are 26 letters: A, B, C, till X, Y, Z. In fact, in our processing, the English letter will be looked as numbers. Letter A corresponding to 0, letter B corresponding to 1, letter C corresponding to 2, and so on. So someone can tell me letter Y corresponding to which number? Yes, one student answered me that letter Y corresponding to 24. Okay, let us have another try. Letter Z corresponding to which number? Someone can answer this question? Yes, letter Z corresponding to 25. So you should remember, from letter A to letter Z, there are totally 26 letters. They are corresponding to they are corresponding to 0 to 25, not 1 to 26. So when we use this set of numbers, we get a set of elements in which the number of elements are 26. If we want to add 2 elements in this set, for example, 2 and 3, if we add 2 and 3, what we get? Okay, some student answers that add 2 and 3, then we get 5. Yes, surely it's right. It's right. And then we ask another question. If we add 2 and 25, what we get? 2 and 25? I'm waiting for someone can tell me the answer. 2 and 25? Yes. Somebody answered me that the result is 27 because 2 and 25, when we add them together, we get 27. But there is a problem. The set is a finite set. There are just 26 elements, 0 to 25, but the result 27 is not in the set. So we must have a method to limit the addition result in this set again. So when we get 27, how do we get the real result in this set? The answer is 1. Anybody can tell me how to get this result from 27 to 1? Yes, we must divide the 27 by 26, and then the new result is the remainder of the division operation. So another try again. If we add 10 and 20, 10 and 20, 10 and 20. Okay, one student answered me that the answer is 4. Yes, it's right. Because when we add 10 and 20, we get 30. But 30 is not in the set. So we must do the same thing as before. We must divide 30 by 26, and we get the remainder 4. So everybody, please remember, when we add 2 elements in this finite set, we must add them together like normal integer. But when the result is greater than 25, we must divide the result by 26 and get the remainder as the last result. So in professional term in mathematics, what's this set? Anybody can answer this question? Yes, it's a ring. A ring is a finite set in which we can do addition, subtraction, and multiplication. Not necessarily division. In this example, we use a ring of 26 elements. It's just a ring, not a field. So Now you can send